My name is Ray Morris, and today's short lesson is about residential breakers. It's a basic electrical breaker identification and knowledge, just so you can identify and get an understanding of what they do. A breaker, basically, what it does is it allows the wire. We've got to size the wire that if it's a 20 amp breaker, we don't want it to go over 20 amps. If it pulls more than 20 amps, we want to be able to break that circuit in some way. We don't want it to keep going because it will melt the insulation around the wire, our conductor, and we don't want that to break down. We want it to last forever. So they developed a way to cut off the power and monitor it to make sure it does not mess up the insulation. Because really, in the end, we're trying to protect the insulation around the wire or the conductor. I keep saying wire, it's the conductor. If we can protect the insulation around the conductor, it will last forever. We're really not trying to protect the conductor because the copper, it can handle the melting point real high. It's the insulation that can't. Most houses have breaker panels. House prior to 1960 may have a fuse panel. Maybe some in the 60s will have fuse panels put in those, but they are trying to do away with those. In this area, if you have a house with a fuse panel, it's the screw-in fuses that people put in a long time ago. If you try to sell that house, most insurance companies will not insure it unless you change it to a breaker panel. And the reason is fuse panels like that, people would take the fuse out because it would blow the fuse for some reason. And they would stick in pennies, aluminum foil, anything that would conduct, they would stick in there, and then they would overload the circuit and burn the house down. So breakers are resettable. You don't have to replace them. They reset. A fuse you had to replace, and if you didn't have the right one, let's say a 20 amp fuse blew, and you look in your workshop and all you have was 30 amp fuses, most time you're going to put that 30 amp fuse in there and you'll say, I'll change it later, and you never do. Most houses have a snap-in, and that's for residential. They do make bolt-in breakers, and that's for commercial type application. It bolts to the bus, and snap-ins snap on to the bus. Residential housing have single pole breakers and double pole breakers. And what that means, there's two phases or buses in a panel. And if you want on a single bus, you get a single pole breaker. If you want to get on both buses at the same time, or both lines of power coming in, you get a double pole breaker. Double pole breakers are usually for higher voltage or higher amperage equipment. If you think about it, your hot water heater, if it's electric, a dryer, if it's electric, your cooktop and range, air conditioner units, they're two pole breakers most of the time because they pull a lot of amps. And hopefully y'all done Ohm's law. If you have something that pulls 20 amps at 120 volts, if you put it at 240 volts, it will only pull 10 amps, so it's less amperage. And so if you think about it, you're getting I can't say better value, but smaller wire can be used with double pole breakers. You don't want a single pole breaker that pulls 60 amps. And then you have to use a number 6 wire, and that's just non-practical, I guess is the best way of putting it. The most popular breaker in the house is a single pole 20 amp breaker. It needs a number 12 wire, which is the yellow Romex, but that's what most people use in this area. There's other places they may use 15 amp breakers, is the most popular for receptacles and lighting, therefore they use the white wire 14 gauge. Larger appliances usually have the double pole breakers. Okay, here is a picture of a single pole 20 amp and 15 amp breakers. These are square D home line breakers. And as you can see, it's supposed to say what size breaker it is on the handle. And these, if you think about it, most of them are mounted sideways. And the reason they're mounted sideways is they're supposed to be in the off position in the down position, I guess you could say here. If you have a breaker upside down and you got to pull it up to turn it off, that's a violation of the code. If you're in an emergency and a panic, it's easier to shut something off pushing it down than pulling it up. And that's where the reasoning comes in. But these are square D home line single pole breakers. Okay, this is a 2-pole 30 amp breaker. Obviously a 30 amp, it needs a number 10 wire because 10 gauge wire is the orange insulation, and it's good for 30 amps. But this is a 2-pole breaker, and it's basically 2 single pole breakers that are pulled together, and it's got one handle on it. These are GFCI breakers and an AFCI breaker. These are square D home line as well. These are single pole 20 amp GFI and AFCI breakers. The GFI is the one on the left, and it's got the yellow button on it. The AFCI has the green button on it. So there's kind of an identifier of which is which. But GFCI breakers are normally used around this area. Most people put GFI receptacles in. If you got a hot tub or something like that requires GFI protection, yes, they use them there. But the green button, the arc fault circuit interrupter, is used for bedrooms. In the code now, you're supposed to have an arc fault breaker for every bedroom. So they're used. So if you got a 3-bedroom house, more than likely you have 3 of those. Some people piggyback, put 2 bedrooms on one circuit because these are about $40 or $50 a breaker. So obviously you can save some money if you put 2 bedrooms on one circuit. But most people put a circuit per bedroom just to kind of cover themselves to make sure everybody's got plenty of amperage. And on the GFI and the AFCI breakers, they have the neutral with them, and they pigtail onto the neutral bus. On these, you got to carry the black wire out to the device and then bring the white wire back to the breaker. And you wire it to the breaker, and then you dump it to the neutral bar on that white pigtail wire. Because what a GFI does is monitor how much power goes out and how much comes back. And so if there's a difference, it's going to trip and say, hey, let's figure out where the other power we're losing it at. And that's the end of my presentation on breakers. I hope you enjoyed it.